Welcome to your extra credit review, starting with our straight line motion and the Big Ten. So we have questions. We are going to be answering questions and then crossing off the answers from the box here as we go. So a particle for letter A moves around the x-axis for t greater than or equal to 0. The position of the particle is given by this lovely function right here. At what time t does the particle change direction? So remember, for changing directions, we only care about the velocity function, and we want to know when does this change signs. Okay, so v of t is going to be x prime of t. And so we take this derivative, we're going to get 2t squared, 3t squared. Remember, move the exponent in front. Minus, bring that 2 in front and make it 18t. And then minus 21, and this just becomes a plus 0 on the end, so we can kind of just leave it off for ourselves. All right, so if we set v of t equal to 0, now remember, in order to change signs, what we're going to really do is set v of t equal to 0, okay? And then we're going to use our sign chart to figure out where it changes signs. So where does v of t equal 0? All right, so if we set 3t squared minus 18t minus 21 equal to 0, I'm going to factor this. Now, all of these numbers have a 3 in common. So if I divide both sides, I really hate putting a 3 underneath just everything because usually one person divides just one of the 3's and not all of them. So this becomes t squared minus 6t minus 7 equal to 0. This is going to factor into t minus 6, I lied, apologize for that, minus 7 times t plus 1, so that it multiplies at negative 7 and gives us negative 6. And if this is true, all right, then we know that either t minus 7 is equal to 0 or t plus 1 is equal to 0. So we are looking either at t equals 7 or t equals negative 1. This is where the particle has stopped moving, okay? What we really want to do is create a sign chart for ourselves. So these two numbers, negative 1 and 7, are the numbers we care about. We're going to pick numbers around them. So for example, 0, negative 2, and how about 10, okay? And we want to know what are the signs of these numbers that we're plugging in. So I'm just going to change colors here for these numbers. Don't mind me. All right. That didn't work. Okay. We'll try that again. So that we can focus on what numbers we're actually talking about here. 0 and 10. All right. So if I do v, right, v of negative 2, what happens? All right, v of negative 2 is going to be 3 times negative 2 squared minus 18 times negative 2 minus 21. And all I want to know is this positive or negative? That's it. That's all I care about. Okay, so this is 3 times 4, which is 12. This is positive 18 times negative 2, so that's positive 36. Take away 21, and we all can agree that v of negative 2 is going to be greater than 0. Doesn't matter what it is necessarily. We just know it's going to be greater than 0. I think it's going to be 27, but it's going to be greater than 0. Okay? The same thing for, so all the numbers over here are going to be positive. All right? So now I'm going to try v of 0. So v of 0, and I wanted to change colors. V of 0 is equal to 3 times 0 squared minus 18 times 0 minus 21. We can all agree that this is going to be negative 21 and it's going to be less than 0. So we are negative for all the numbers that are inside of that. And then we also want to check, right, what is v of 7? So v of 7 is 3 times 7 squared minus 18 times 7 minus 21. Okay, so the next one we have to check, the last one, is where, remember, where t is equal to 10. So we can check v of 10, and that's going to equal 10 cubed. Oh, we want to do the velocity. 3 times 10 squared minus 18 times 10 minus 21. So 10 squared is 100, this is 300 minus 180 minus 21. And we can all agree that this is going to be greater than 0. That's all we care about right now, is it's going to be positive. I think this is what, 280, so it's like a 99, I think, ends up being, and greater than 0. Okay, so we know that from the get-go just to start with. When does it change directions? When it switches from at -1, because we go from positive to negative, and at 7 because we go from negative to positive. That's it. Okay? So we can say the particle changes directions at t equals -1 and t equals 7, right? That's the times where it stops. So it's changing directions at those times. Okay? Since the velocity changes signs all right, and that's pretty much it. That's all we have to say. And we could say at those times, so at those times. Okay, so we have positive switching to negative, negative switching to positive. And the reason we're also allowed to make the statement is because we show the work for what those other values are. All right, so we can cross off 1 and 7, I believe. All right. Letter B, a bug is moving back and forth in a straight path. Velocity bug is given by the equation. Find the average acceleration of the bug over the interval. Now this is key. Average acceleration means that we want to do the slope of the velocity. Okay, slope of the velocity. Because remember, the derivative of the acceleration is the slope of the velocity, okay? So we're going to do the average acceleration from 1 to 4. All right, we can write down slope, or we kind of want to write my average acceleration. ELE. That's a terrible writing. Sorry about that. Okay, and it's going to be v of the upper part of the interval, v to 4 minus v of 1 over 4 minus 1. And if you switch these around and did v of 1 minus v of 4, as long as you did 1 minus 4, this will still work. Now, for v of 4, we're going to have to actually go figure that out by plugging in. So v of 4 is equal to 4 squared minus 3 times 4. That's 16 minus 12, which is 4. So 4 minus v of 1 is 1 squared minus 3 times 1. So that's -2. And then we're going to go ahead and plug in here. Just double checking something, all right? Divided by 4 minus 1. So we're going to get 4 minus the -1, which is 6, over 3, which is 2. And that is my average acceleration over that time. And we can go up and cross 2 off. Oh, and by the way, time out. On the last question, I just thought about this. and I have to apologize, that we cannot take this answer, by the way, because our t has to be greater than 0. So we could have actually made it easier by ignoring, right? We didn't actually have to do the -2. We just had to actually check 7. So we would have had to plug this in and do v of 0, and then do v of 10 to see what's going on around it. We did need to do v of -2. But if this question was just asking in general for any t value, that's how we would essentially have done that question. So just a little edit there. All right, for C. The velocity of the particle from t in between 0 and 9 and including 0 and 9 is given in the graph above. Which of the following values is the particle speeding up? Now remember, this is the velocity. So we know that we want to have the same sign. We want to know where is v of t greater than 0, and then where is v of t less than 0, okay? And then we're also going to check that with the acceleration. So where is v of t greater than 0? It's greater than 0 anywhere here that we are above the y-axis. So all that spots from 0 to 4, essentially. And when is it less than 0? Is when this graph, because it's v of t, okay, is below the x-axis. So all the way down here from 0, or I should say from 4 to 9. Okay, next question. Where is a of t greater than 0? Now remember, a of t is the derivative of this, or the slope of the graph. So you can see everywhere from where this vertex occurs, okay, this whole part of the line has a positive slope up until there. And then where this vertex occurs, it has a positive slope all the way to there. Okay, so we'll call this the interval from 0 to, let's say, I don't know, just below 2. All right, we'll call it like 1.8, I guess, maybe. And then a of also from what looks to be just about 7, say approximately 7, all the way to 9. Okay, and then where's a of t less than 0? It's less than 0 when this line has negative slope, and that happens all the way down to here. So it happens from about 1.8 to just about 7. So anywhere in between where these match, any of the numbers here match, or any of these numbers match, okay, we have speeding up. So from 0 to about 1.8, and then from 4 to about 7 is where we are speeding up for sure. We can't necessarily include 7, and we can't really include 4 per se, because remember, the velocity doesn't include 4, because technically the velocity is 0 and it's stopped. So we want to pick a number that kind of demonstrates what's going on here. And we can see that 5, so 3 doesn't work, right? Because the velocity would be here is positive, but the acceleration is negative. So this is out. 4 doesn't work because the velocity is actually equal to 0. And 7 doesn't work because this point is a little bit outside of that. So it's I think, for me, 7 has a positive acceleration here, okay, and a negative velocity. So I would say that this is also out. The best answer is definitely 5, okay? It's better than 4 because the velocity here is negative for sure, and the acceleration is for sure negative. Here we kind of have a debate. I don't really know. Well, if the acceleration is negative or positive directly at 7. So go with the one that makes the most sense here. All right, we can cross off 5 from our... All right, for letter D, we have 2 particles, P and Q. We're given time values between 0 and 10. The position of P can be modeled by this lovely graph. And the particles P's position, velocity, and acceleration is modeled by the chart. At what time are P and Q moving towards each other? Now, the key thing here to start off with is we're really only talking about these 4 times. So keep in mind that you don't have to worry about the whole graph. We just want to worry about these 4 times, essentially. So let's talk about what happens at each one of these times. So at t equals 1, what's happening? For particle P, okay, xp of 1 is equal to, and you can see right here, is equal to 2, okay? And for q, we have xp of 1 is 4. I should say q of 1, right? It's particle q. Now, remember, to be moving towards each other, they have to either be one to the left and one to the right, okay? So one of them is placed here, let's say P and Q are placed left and right from each other, and the one on the left has to be moving to the right, so a positive velocity, and the one on the left one on the right side needs to be moving towards the left, so a negative velocity. So we have to check to see which one is placed where, and then which direction we're moving. All right, and then we want to know the velocity. Now the velocity P of 1 is just the slope of 1, and here we can see we're going down 1 and over 1, so that's negative 1. And then for the VQ of 1, you can use our chart and see that this is 3. So in general, P is located here at 2, there's P. Q is located here at 4. P is moving to the left, and Q is moving to the right. And so these are going away from each other. All right. For time t equals 3, what's happening? We're doing the same thing now. So for p, xp of 3, right, is right here. It's actually just equal to 0. So it's located at 0. And then xvp, right, because we want to do the velocity next, also has the same slope, so it's negative 1. The position function for q at 3 is 1. And the velocity function for q at 3 is negative 2. So if we put them on a number line here to kind of make sense of it, p is located at 0. Q is located at 1. P is moving to the left. And Q is moving to the left. Okay? So they're not technically moving towards each other again. All right, so keep that in mind. Oh, actually, time out. We made a mistake here. This is not negative 2. That's the acceleration. This is 0. So that means this is stopped because this is equal to 0. So that means that these are not moving. This is actually moving away because this one isn't moving and this one's going to the left. So these are also moving away from one another. Okay, for time t equals 7, same thing we want to check. So xp of 7, so find 7 right here. It's about a half, say approximately a half. And then vp of 7 is the slope. You can see we're going up 1 and over 2, so that's 1/2 and positive. And then xq of 7 and vq of 7 we can get right from the chart. So we're placed at negative 1, and the velocity is negative 2. And then we can see from our number line, p is currently placed at 1/2. Q is placed at negative 1. Q is moving to the left. P is moving to the right. And these are once again traveling away from one another. And the last one is at time 9. So xp of 9. We want to do vp of 9. So when we're at 9, we're down here at negative 1. And the slope of this line is down 2 over 1. That's negative 2 for the velocity. Okay, xq of 9 and vq of 9 are next. So 9 and xq is negative 2, and v is 3. And it looks promising. So starting at negative 2 is q, and it is moving to the right. And at negative 1, we have p moving to the left, and these are going towards one another. Hey, so we got one. Where t is equal to 9, these are moving towards. That's it. Didn't say to explain, so just the work is fine. And now we can go up and cross off 9. All right. Letter E, position of the bug is moving up and down a vertical post by the equation. Find V of 3. Okay, so once again, V of 3 is going to equal Y prime of 3. And I am not looking forward to doing this, but we can do it. All right, so we're taking the derivative with respect to t. So this negative 12 pi is a constant, and the derivative of a constant times a function, we just leave the constant alone and then multiply it times the derivative of this guy. Now the derivative of cosine is negative sine, and then we also need to do a chain rule and multiply times the derivative of the inside, which since it has a t, this becomes 1, and we just get pi over 6 left over. Plus, derivative of 6t is just 6, and the derivative of 1 is just 0. So that is my function. So now v of 3 is going to equal, and really what I should have done first, instead of made these 3, is kept these as t's, because I'm not plugging in yet. Now I'm going to plug in. So negative 12 over pi times negative sine, so really this is just going to be positive in a second, and this is 3 pi over 6, which is pi over 2, times pi over 6 plus 6. So let's go to the right here. Negative 12 pi over pi. All right, on the top, times negative sine of pi over 2 times pi over 6 plus 6. And then we can kind of clean this up. So remember, pi over 2 in the unit circle is really going to be, this is pi, this is 0, this is pi over 2. And we're doing the sine value, so this is really just 1, okay? So we have this negative 12 over pi times negative 1 times, and it's negative 1 because it was negative sine of pi over 12, and then pi over 6 plus 6. So this really becomes negative 12 over pi times negative pi over 6. We see what's going to happen here? Plus 6, which is really negative 12 pi over 6 pi. So the pi's are gone. This becomes negative 2. We have a final answer of 4. Wait, 2 negatives. Oh, look out now. Positive. We get 8. Double checking answers. Negative times a negative is a positive, so positive 12 over 6 is 2, and 2 plus 6 gives me 8. So V, right? V of 3 is equal to 8. All right, 2, 1. A particle is moving along the x-axis. The position and velocity of the particle is recorded for various times in the table below. At which time is the particle moving towards the origin? Okay, so we want to basically look and see what's happening at each of these times. And remember, we want to know where we are and what direction we're moving in, okay? So if you think about it, all right, at t equals 1, so here's, let's say that 0 is located right here. So our particle at t equals 1 is located at 3. We'll put a 3 up here. That's t equals 1. And it is currently has a positive velocity. It's moving to the right. That's not moving toward the origin, okay? Now, at t equals 2, the position function is at 0. So at t equals 2, we're at 0. And it's positive velocity. It's moving into the right, which is also away from the origin, right? We're at the origin, but we're moving to the right. So it's not towards it, okay? At 4, we're located at negative 1. That's t equals 4. But because our velocity is negative, we're moving to the left, which is away from the origin. Okay? And at t equals 6, we're at, or at -4, for t equals 6, and our velocity is positive, so we're moving to the right. So notice we're left of the origin, but moving to the right, that's toward the origin. Awesome. And then at t equals 8, we're located at 5 over here. T equals 8. But our velocity is such that we're just standing still because the velocity is equal to 0. It's not moving it left or right at all. Okay? Not moving. So the only time where we are positioned, so we are left or right of the origin and moving towards the origin, is at 6. Okay? So we're going to say at t equals 6, the particle is moving toward the origin. And if this is a test or a quiz, you've got to explain why. So why is it? Since x of 6 is equal to -4, the particle is left of the origin. And v of 6 is equal to -3, or +3, sorry. And it is moving right, comma, toward the origin. And that would give you full credit. All right, so we can cross off 6. All right. Next one. Velocity of a particle is given on the graph below. How many times interval does a particle change directions? So remember, we need to, A, we need to hit 0, and B, we need to be positive to negative and negative to positive. So the particle changes directions. Now you can use your number chart here, right? We're positive up until this point. Then we switch to negative. Here we stay negative, right? So even though it got to 0, right, at these values, it stayed negative around 9, but it changed around 6, okay? Changes directions at t equals 6, since the velocity changed from, we could get specific, right? We could just say change signs. Changed signs. You could say change signs from positive to negative. We'll get there a little bit later at that time. Or at t equals 6 seconds. So that's it. Cool? All right. Letter H, position of the bug, moved along a straight line given by the function. At what time t is the instantaneous velocity equal to the average velocity on a bug on the interval from 0 to 6? So what we want to do is do the average velocity first. So the average velocity, and then what we know, once we know the average velocity, then we can set s prime of t equal to the average velocity, and then solve for t. Remember, we're going to get the average velocity by plugging into the position function, okay? So that's s of 6 minus s of 0 over 6 minus 0. Now, if we plug 6 in, that's 6 squared, 36, minus 2 times 6, which is 12, so 24, plus 3. So this is equal to 27. And then s of 0 is 0 squared minus 2 times 0 plus 3. So that's just equal to 3. So this is equal to 27 minus 3 over, and then 6 minus 0 is 6. So 24 over 6 is just 4. So now all I have to do is set s of t equal to 4 in solve. Or s prime of t, I should say. So s prime of t equals, and this is 2t minus 2. Okay, therefore, the average, well, actually, we'll save that to the end. Sorry about that, I'm jumping ahead of myself. So we're going to set s prime of t equal to 4. So 4 equals 2t minus 2. Add 2 to both sides to get 6 equals 2t. And divide by 2 to get 3 is equal to t. We can say, therefore, the average velocity, okay, is equals the instantaneous velocity at t equals 3 seconds. All right, awesome. Let's go cross off 3. I, the velocity of objects, is graphed above for this one. What is the velocity object when the acceleration is equal to 0? Now remember, the acceleration equal to 0 means it's where the velocity, the derivative of the velocity, is equal to 0. This is only true when there is a horizontal tangent line. So I can draw a horizontal tangent line here, okay, and that's it. Okay, so v prime of t is going to equal 0 when, which really, remember, is a of t, when t is equal to 3, because that's when our horizontal tangent lines. We want to know what's the velocity of that point. So v of 3 is just equal to what is the y value on the graph, and so that y value hits here. So v of 3, I should say, is just equal to 4. That's it. That's our answer. Okay? So we use the horizontal tangent line to figure out when the acceleration was equal to 0, and then we plug that value into our function, or just check what the y value is on the graph for our answer. All right, and we got one more left. The position of the bug moving across the x-axis is given by the function, where a and b are both non-zero. Find the acceleration of the bug at any time t. All right. So if our position function is given by at plus b, then our velocity function is equal to the derivative of the position function. And the derivative of this function is just a. And the acceleration would be the derivative of the velocity, and the derivative of a, which is a constant because they're non-zero numbers, is just 0. Therefore, a of t is just equal to 0. And that's it. Hopefully that made a lot of sense so you guys could follow along. If you have any questions, we'll go over this a little bit tomorrow, as well as the end of the lesson 4.2 before your quiz. Have a great day.